to the lecture. My name is Sonan Jamil. Today we will see impulse invariant design method to design IIR filter. So let's start with some explanation from the book. Now if the given transfer function is in for analog filter, then an analog impulse response can easily be formed by inverse Laplace transform. To replace the analog filter by equivalent digital filter, we apply an approximation in the time domain in which the digital filter impulse response must be equivalent to the analog impulse response. Therefore, we can sample the analog impulse response to get digital impulse response and take the Z transform of the sampled analog impulse response to obtain transfer function. First of all, this is the explanation. The analog impulse response can be achieved by taking the inverse Laplace transform. So we just have to take the inverse Laplace transform of the impulse response, then sampling, applying the sampling and taking the Z transform. So let's start with an example. This is the example. We are asked consider the following Laplace transform. We are given the Laplace transform. Determine h of z using the impulse invariant method of sampling rate is given, which is 10. So first of all, we will have to take the inverse Laplace transform. So using the Laplace properties of inverse Laplace transform, just if we are given the transfer function as a over s plus a, it will come out to be a into e power a t u of t. So just in this case a is replaced by 2, so h of t will be 2 into e power minus 2 t u of t. Then sampling, just replacing the t with n of t and substituting the values of t, then taking the Z transform of the above result, it will come out to be, we will take Z transform by using this property or formula, which is, if we take the Z transform of e power minus an u of n, it will come out to be z over z minus e power minus a. So just e power minus a, here a is 0.2 because in the previous result we have seen that a is 0.2. So substituting the values, then this will be the transfer function of the desired filter. So that's it for today's lecture. Thanks very much for watching.